What if I told you the universe is whispering 3 terrifying secrets, and most of us are just ignoring them? These secrets blow apart our most sacred assumptions. A particle shouldn't exist, yet it roams our reality. Black holes swallow everything, including the laws of physics themselves. And there's a hidden cosmic web anchoring it all, built on dark matter and dark energy. None of this is science fiction. These are truths being discovered right now. By the end of this video, your understanding of reality may never be the same. In 2023 and 2025, the Muon G2 experiment at Fermilab published results that shook the foundations of physics. Muon, the heavier cousin of the electron, behaves like a tiny spinning magnet. Scientists measure how it rotates inside a powerful magnetic field. Theory predicts one exact value, known as G2, with astonishing precision. But reality refused to comply. The measured value didn't match the theoretical prediction. This tiny mismatch, by parts per million, is not a slip. It's a glaring red flag. It might hint at a 5th fundamental force or particles beyond the standard model. Big think +1. Historically, the measurement began at Brookhaven, then moved to Fermilab. Over years, the precision improved, yet the anomaly stubbornly persisted. +1. If confirmed at the 5 sigma level this year, this is not just new physics, it's a revolution. We'd have to rewrite textbooks. We'd have to ask, what else is hiding in the quantum shadows? Step into the abyss now. Black holes. According to general relativity, they swallow everything, even information. Stephen Hawking discovered they emit radiation, slowly evaporating over eons. But here's the nightmare. If a black hole evaporates, the information about the matter it consumed seems lost forever. That breaks a fundamental rule of quantum mechanics. Information cannot be lost. This is the black hole information paradox. At stake, the reliability of physics itself. Recent developments suggest solutions. The holographic principle says, what if the universe is lying to us? What if everything you think you know about science, about space, time, and reality itself, is just the surface of something far stranger? Tonight, we're not looking at theories or science fiction. We're looking at real mysteries that scientists still can't explain. A particle that shouldn't exist, yet appears in experiments. Black holes that swallow not just matter, but the very laws of physics. And a hidden cosmic web connecting everything, stretching across the universe like a neural network. These aren't small puzzles. They are cracks in the foundations of reality. And if you follow them deep enough, they lead to one terrifying conclusion: that the universe is stranger than we can even imagine. Part 1. The particle that shouldn't exist. 1 to 5. Let's begin small, not with galaxies, but with a single particle. Like the electron, it carries a negative charge and spins like a tiny magnet. In theory, we know exactly how it should behave. The standard model, our best description of all particles and forces, predicts its magnetic wobble with extraordinary precision. But when scientists measured it, something was wrong. The wobble didn't match the prediction, not by a rounding error, not by human mistake, but by enough to suggest the standard model itself is incomplete. This discovery didn't happen overnight. The story begins in the 1990s at Brookhaven National Laboratory, where early measurements hinted at something strange. Later, the massive Fermilab experiment pushed the precision even further. Huge magnetic rings, cooled to near absolute zero, were used to trap and measure muons spinning in perfect circles. The result? Again and again, the data pointed to the same anomaly. The muons weren't obeying the rules. This tiny discrepancy may seem small, just a few parts per million. But in physics, even a tiny crack can bring down an entire wall. If the standard model can't predict the muon, what else is it failing to explain? Some theorists suggest it's the first hint of a fifth fundamental force of nature. Others believe it points to supersymmetric particles, shadows of reality that could link us to dark matter. And some whisper about hidden dimensions bleeding into ours. Imagine that, a particle flickering between worlds, behaving as if reality itself is glitching. If this anomaly is real, it could mean the universe we know is just a fraction of something much larger and far stranger. Part 2. The Black Hole Paradox, 5 to 9. Now let's zoom out from the tiniest particle to the most terrifying giants in the universe. Black holes. We know how they form. Massive stars collapse, crushing matter into a point of infinite density. Gravity becomes so strong that nothing, not even light, can escape. At their edge lies the event horizon, a one-way door to oblivion. But the true nightmare is not what they swallow. It's what happens after. In the 1970s, Stephen Hawking made a shocking discovery. Black holes are not eternal. They leak energy, slowly evaporating over time through what we now call Hawking radiation. But here's the paradox. If black holes evaporate completely, what happens to the information about everything they consumed? Quantum mechanics tells us information can never be destroyed. But relativity suggests black holes erase it forever. Both can't be true. This is the black hole information paradox, and it's one of the greatest unsolved problems in physics. Over decades, countless solutions have been proposed. Some scientists argue the information is stored on the event horizon, projected in 2 dimensions like a hologram, giving rise to the holographic principle. Others suggest black holes may be gateways, wormholes, transferring information somewhere else. String theorists propose the fuzzball model, where black holes are not singularities, but tangled knots of energy that preserve data. And more recently, physicists have suggested the soft hair hypothesis, faint quantum signatures at the horizon that record what falls inside. But none of these answers are proven. The paradox remains. Think about what that means. We live in a universe where reality itself may erase its own memory. If information truly disappears, then the laws of physics collapse with it. And if information survives, hidden in ways we can't yet detect, then black holes are not just cosmic monsters, they are libraries. Libraries holding the most forbidden knowledge in the cosmos. Now let's zoom even further. Beyond stars, beyond galaxies, to the structure of the universe itself. For centuries, we thought the cosmos was random, chaotic, scattered. But in recent decades, astronomers have mapped the universe in 3 dimensions, and what they found is breathtaking. Galaxies are not isolated. They cluster along invisible filaments, stretching for billions of light years. Together, these filaments form the cosmic web, the largest structure in the universe. Imagine a spiderweb of light stretched across infinity, with galaxies like glowing pearls strung along invisible threads. This web connects clusters of galaxies the way neurons connect inside a brain. It's as if the universe itself is wired. But what makes up this web? Not ordinary matter. Not stars, not planets, not gas. It's woven from dark matter, an invisible substance we can't see or touch, but that outweighs everything else in the cosmos. Without dark matter, galaxies would simply fly apart. And threading through the web is dark energy, a mysterious force pushing the universe to expand faster and faster. Together, Dark matter and dark energy make up 95% of the universe. The visible stars, planets, and galaxies we see, just 5%. That means most of reality is hidden. And the cosmic web may be the blueprint, the skeleton of this hidden universe. Some scientists wonder if this structure is truly random, or if it's a kind of code, a pattern etched into space-time itself. If the cosmic web resembles a brain, could it also process information, like a mind on a cosmic scale? Three mysteries: a particle that refuses to obey the laws of physics, black holes that swallow not just matter, but the very rules of reality, and a hidden web that connects everything across the universe. On their own, each is strange enough. Together, they suggest something deeper. From the smallest particle to the largest structure, reality is filled with cracks. And through those cracks, another truth is leaking in. Maybe our universe isn't the final version. Maybe it's just one layer of something bigger, a code, a simulation, or a multiverse of infinite variations. What if the universe is not only stranger than we imagine, but stranger than we can imagine? The cosmos doesn't give up its secrets easily. But every anomaly, every paradox, every hidden pattern is a message. A message that says, we're missing something big. The question is, when we finally uncover it, will we still recognize the universe we thought we knew? Ramation isn't lost, just stored at the event horizon. Reality may be like a vast projection. WIRED. The soft hair concept posits that low-energy quantum excitations on the horizon preserve information. Space. The fuzzball conjecture replaces singularities with tangled strings. Black holes become complex structures capable of storing information. WIRED. A brand new idea, the quantum memory matrix, QMM, suggests space-time itself preserves quantum data in its fabric. Information truly never vanishes. The quantum insider. If these theories are right, reality holds on to its secrets, hiding them in ripple effects, microscopic structures, or cosmic geometry. If even one of them proves valid, we're looking at a universe far more intricate and strange than we ever dreamed. Zooming out from black holes, let's look at the cosmic landscape. Galaxies are not randomly scattered. Instead, they form a web-like structure spanning trillions of miles, the cosmic web. Filaments of dark matter stretch across the cosmos. Galaxies climb along these invisible threads. Mapping this structure reveals order hidden in chaos. Dark energy drives expansion. Dark matter gives shape. This web could be nature's coding crust, a design scaffold for the universe itself. What if these three mysteries are connected? The muon anomaly challenges the quantum micro. The information paradox challenges core physical laws. The cosmic web reveals a large-scale architecture we barely understand. Once seen together, they form a message. Our models of reality are incomplete. They hint at unseen laws, hidden dimensions, or cosmic truths too deep for our current theories. We are confronted with a cosmos far stranger than science has yet dared to say. Picture this. Our universe is not just a playground of laws, it is a layered symphony, coded in anomalies, entangled information, and webbed structures. One day, as we unravel these anomalies, we might discover that our reality is both simpler and more astonishing than we thought. But first, we must admit the cracks. Reality is whispering. Are you listening?